Algebra 1, Section 6.1, slope and rate of change, or probably should say rate of change, which leads to slope. And we'll start with an example here, cost to rent a tool. Say you go to Home Depot or Kingsland or whatever where they rent tools, and it's $50 for the first day, and then it's, well, I don't want to give the number away, but it's $80 for 2 days, $110 for 3 days. That's not a consistent $50, and some companies do charge this way. What I'd like to point out is that since these go consecutive, 1, 2, 3, 4, 5, we could find out the per day charge by picking really any 2 points that we want to. So for example, let's just pick the first two. And 80 minus 50 is what you get charged between day 1 and day 2. Obviously, that's 30. The full calculation is that you're doing 80 minus 50 over 2 minus 1. You don't really bother with the 2 minus 1 because you know that's just 1 day. But what that is then is 30 over 1. Or if I picked a different set of points, so what if I did the 4th and the 5th day? You'd go 170 minus 140 over 5 minus 4. And again, you'd get 30 over 1, which is just 30. And I guess the point to be made then is really you could pick any 2 points. Let's just pick the last one and the second one. And if I did 170 minus 80 over 5 minus 2, again, that's the cost, right? The cost from the more expensive day to the less expensive day divided by the number of days that are between those two costs would be 90 over 3, which reduces to 30. Okay, so what we have is a consistent rate of change. What we're calculating here would be known as rate of change. Okay, now what's not really the focus of this lesson is writing the equation, and we did have some practice at that in an earlier chapter, and we'll formalize that a little bit with a form of a specific form of an equation of lines. We're going to have 3 different forms. One would be really conducive to what we're talking about right here, but it's beyond the scope of this section. We'll come up to that soon. But it's worth just noting that obviously you're not paying $30 on the first day, you're paying $50. So it's kind of like a built-in $20 charge, right? It's $30 per day plus an extra $20 for the first day, okay? And again, we'll deal with that. We've dealt with that in the past. We'll formalize it in the future, but that's all we really need to say about that right now. So look at then this little calculation here. We just talked about rate of change, and how did we calculate that? Well, we took the change in the dependent variable, which was in the second column, and divided it by the change in the independent variable. That's what this is saying here. Remember, dv is dependent variable, iv is independent variable. I just like to abbreviate them. If we looked at these on a graph, then this would be the change in the dependent variable would be vertical, where the change in the independent variable would be horizontal. Vertical change over horizontal change, which then leads to something you probably have heard before, even if you hadn't heard of these other two more primitive or less used fractions. You probably heard rise over run, okay? And rise over run would lead to this calculation, and this is what we really want to talk about. We want to talk about rise over run leading to the calculation that is y2 minus y1 over x2 minus x1, which is going to lead us then to slope. Rate of change is kind of like the real example to an abstract problem that deals with just slope. I have a funny story about y2 minus y1 over x2 minus x1. Remind me in class and I'll tell you the story. If you don't remind me, I might forget, so remind me. Okay, it has to do with algebra geometry from a couple years ago. All right, so with that in mind, then let's look at some examples. Below is a graph of the distance traveled by a motorcycle from its starting point. Find the rate of change and explain what this rate of change means. Now, they've picked out a couple of points for us, so I wouldn't use anything other than the points that they've picked out for us. I could see that we could probably get some other reasonable points at a certain point. I don't know, though. I mean, that's not good. I think the ones they picked for us are probably pretty much the best accurate ones. So this is the point 20, 400, and this is the point obviously 0, 0. So you could calculate the rate of change by going 400 minus 0 over 20 minus 0. Basically subtracting the y's in the numerator, subtracting the x's in the denominator. 400 minus 0 is 0, 20 minus 0, 400 minus 0 is 400, 20 minus 0 is 20. 400 divided by 20 would be 20. Which is to say then that our rate of change is 20. So for every 1 we go to the right, we go up 20. That would mean if we go 4 to the right, we'd go up 80. About here then, wouldn't that be the point 480? And then here would be 8 160. I'm just going up by 80s because it go by 4 over. If it's over 1 up 20, then it's going to be over 4 up 80. So here's 8 160. Here's 12 240. And here's 16 320, and then here's 20 400. I'm just going up by 80s each time, again, because the scale here is by 4s. Look at the next one. Find the slope of each line. So quickly we changed the conversation from rate of change to slope. And now they want us to find the slope. That has to do with rise over run. They're kind of modeling this for you already, so let's just show that it's down 3 and right 2. The red line is down 3, right 2. You don't have to use the points that they used in this case. Look, I could do this here. There's going to be consistency with slope. I could do it up here. All of these are down 3, right 2. That would be rise over run, which is down 3. That's negative 3. Rise is up and down. Run is left and right. And since we're going right, that's positive. That'd be 2. So it's the fraction negative 3 over 2. That's your rise over run. Now, the other thing you could do, and I think this will happen in a later problem, so I won't talk about it too much, but you absolutely could take the 2 points and plug them in. Your x's are 0 and 2. Your y's are 4 and 1. You could plug the 4 and the 1 here, and the 0 and 2 here. You'd get the same fraction. I'd want to move on to the next one, though. I think we'll deal with that formula a little later. In fact, there it is right there. They did use it in their calculation. Negative 3 over 2. Here's another one. Notice it's got a slope that's going up. As you go right, this slope is going up. That's going to be positive, whereas the previous one, negative slope, is going down. This one's going up. Again, as you go to the right, I think of it like as you read left to right, so it's kind of easy to think of going left to right. This line is going up. That's going to have a positive number for a slope. And the rise of a run is up 2, right 1, up 2, right 1. I could start all the way down here. Up 2, right 1, up 2, right 1. And there you go. And so that's going to have a slope of 2. Rise over run is 2 over 1, which is 2. And then here's a one where they give us 2 points, but they don't really give us a graph modeling. Now, if you want to, you could plot these on graph paper and you could see the modeling. But really what we want to emphasize is now this slope. And by the way, in a future section, we will call the slope M. So I might as well introduce that to you now. M is the slope. Our calculation is y2 minus y1 over x2 minus x1. Make sure you get to know this calculation or this formula as you do these calculations. Now the key here is whichever way you decide to subtract, you have to do that in the same way. So if I decide to go negative 1 minus negative 2, negative 1 minus negative 2 over, you got to do it in the same direction. You now have to go negative 2 minus 3. You can't do it the other way around. Now, if you had done it the other way around from the start, negative 2 minus negative 1, then yes, you need to go 3 minus negative 2. And check it if you want to, you will get the same number. This would be 1. Negative 1 plus 2 is positive 1 over negative 5. Now, what's that? A positive divided by negative is a negative fraction that is 1/5. Negative 1/5. Okay, one more. Find the slope of each line. Let me just show you real quick. They're going to do the same calculation for the slope. But this time, in the numerator, you get 2 minus 2. Well, 2 minus 2 is 0. Now, here's the question. Is that okay? Is it okay to have 0/5? Is that a real number? That is a real number. 0/5 is just 0. It's like you cut tonight's dinner. So let's say you have a casserole for dinner and you cut it into fifths. And then you decide to not eat any of it. You had 0/5 of the casserole. That's okay, right? That's a real number. You just ate 0. So no problem with 0 being in the numerator. 0/5 is just 0. That means that the slope of this line is 0. The slope of this horizontal line is 0. Now, keep that in mind or kind of commit that to memory because that's going to be the slope of every horizontal line. Wouldn't matter where I drew the horizontal line. If I drew it differently in a different place, it's still going to have this same idea. Whatever y value you pick from one point is going to be the same number as a different point, and then you're going to go that number minus that number, whatever that number is going to be 0. 2 minus 2, or 10 minus 10, or -5 minus -5, or a million minus a million. And all those are going to have a numerator of 0, which means all horizontal lines have a slope of 0. Contrast that with this one, where you have a vertical line. And again, they'll just plug this into the slope formula. I don't think you need to do this, but they're just modeling it for you one time. And this time the numerator comes out to something meaningful, but the denominator is 0. Now this is a problem. This is not a real number. Think about it like this. Again, I just used food. Let's talk about pizza. I could cut a pizza into eighths. By the way, I used to work the cut table at Pizza Hut. I was a master cut table person. Yeah, I'm bragging. You could cut it into eighths. You could cut it into fourths. This is what we cut the personal pans into. If you wanted to, you could cut it in half. If you wanted to, you could cut it not at all, which means you cut it into 1. But how could I cut this thing into 0? You can't take a whole pizza and cut it into zeros. So this number is actually undefined, which means the slope of any vertical line, this line or any other line that's vertical, is going to have undefined slope. So horizontal lines, 0 slope. Vertical lines, undefined slope. Okay? And then finally, that just leads me to this summary then, that I just took a snapshot from your textbook. And it gives kind of the 4 possibilities. We just dealt with this one, which is a horizontal line that has a slope of 0. This one, which is a vertical line that has a slope that is undefined. And then we did also see an example where we had not these 2 exceptions, but just a line that has a slope that's going up. As you go right, it goes up. That's going to have positive slope, meaning that the slope is going to be a number that is positive. And this one's going to have negative slope. As you go right, this is going down. It's down, right, down, right, down, right. Thanks for watching.